Hello everyone, my name is Julio Monteiro and today I'll be showing you a little bit how machine learning works, especially in the context of identifying whether a house is messy or not. And I'll focus a little bit on the data aspect of this project, not as much the code, but the importance of understanding data and the impact it does to our predictions in understanding a machine learning model. Um, so we want to identify whether a room is messy or not. In order for us to do that, we need to give proper data. And when I say data, we need a lot of data because we want it to be scalable as well, not only to one specific room or one specific type of house. And that's why I decided to use a library called ResNet in the TensorFlow package. ResNet is a library with thousands and thousands of all types of photos. So the model is well trained in a variety of things. But we wanted to focus on rooms of a house. And that's why we have a fine-tune function here. And before I dive into showing you a little bit of the code, I want to talk a little bit more about the data because that's one of the most important parts of this prediction that we want to have. So we know that we have already a lot of data from the ResNet 50 library, but now we need data of rooms. And that's why here I have lots of photos of clean houses, and they're all different houses. And then also lots of photos of messy houses. And all these photos I got from the internet. So they are very diversified. And then we also have to have test photos. So here I have a test photo that is not used in the training of the model. That's very important. We cannot give the model photos that we will then ask the model to predict because in this case we already know that the model has seen that photo before and it knows what it is. Okay, and then let me show you a little bit about the code itself. So I'm using a model that got 88% accuracy on its predictions. Okay, and this is what this code is. So we're using the ResNet and the TensorFlow Keras, and then we are fine-tuning, meaning that we're giving it the information we want, so it focuses on the data that we're giving, and in this case it's rooms. And then we're training it to identify if a room is clean or messy, and then it saves this model's prediction so I can then use, and that's the model I'm using here. And then here in this main class, that's where we initialize our chore detection class with the ResNet, the image sizes that we're giving. We process the images from ResNet, and then we run predictions with the images that we have given. Okay, so here I'm giving the path for the images that we're testing. I'm gonna run this code to show you the importance. So here the code has already run previously, but it's gonna run again. And then we're going to compare those predictions. So we have 88% accuracy on this, so it's not that great, but it's also not that bad. So let's see how it does. So here we have messy kid, so that would be like a messy bedroom of kids, and it's said to be messy with 100%. Usually 100% is not that good for us to trust because it could mean that the model overfit. But let's see how confident this is. Messy kid, where is it? Messy kid. Okay, so now we can understand why it's a very messy bedroom. Here we have 52%, for example, sala, that means living room. Let's see. Here said to be messy from this angle, but with a very low confidence. From this training, I want everyone to just pay a little bit of attention to the data aspect part of machine learning, because this is where all the difference in your results will make. I hope you enjoyed, and let me know if you have any questions. I will post the slideshow and the code for you to play around with this code. Have a good one.